Alright, so today we're going to talk about the introduction to physics. Not just physics as a science, but also physics as a class here at Juda. Physics is the study of the physical universe, why things happen. We're going to discuss notes in our open course, meaning that basically any notes you take, any formulas, any homework, any test quizzes, those are always available to you from your binder for any test, any quiz, anything. We're going to talk about the difference between laws and theories, and we're going to talk about classical physics today and forces. This is basically most of Chapter 1 of our current textbook. There are 3 parts to your notes that I recommend. First thing is vocab. You have to take the vocab from the book in these videos and make sure you understand and have a way to reference it cleanly. Second thing, and a big part of physics, is math. We are doing equations, we're figuring out how to do certain things, so you're going to need an equation sheet, a section that's clearly defined. We may seriously have 60 to 70 equations before the year is out. So organization of your equation section is important. Finally, work problems, practice, homework, quizzes, whatever. Even my dogs think that is important. Listen to them bark behind that. You have to have problems to reference. Now, let's talk about the difference between a law and a theory. And these are the definitions. A law is a statement of a reoccurring pattern of events. And a theory is an explanation of a phenomenon. And I put those up, and you can record those, but really it comes down to us understanding. Let's start with that. We know what a hypothesis is from our previous science courses. It's an educated guess. It's something we're going to check. A theory summarizes a hypothesis or hypotheses. It's the idea that it is making some sort of conjecture. A law generalizes a body of observations. And to put it into examples, it is a theory that the dinosaurs went extinct because of a meteor strike. That is a theory. There is a law of gravity. Theories tend to explain why, laws typically don't. There are many parts to the physical universe, and we're going to stick to classical physics. There's Newtonian mechanics, or Newton, Isaac Newton, basically the father of that whole branch. Thermodynamics, the study of how heat and things like that change. Electromagnetic theory, magnets, and there's atomic theory at the particle level. Our whole year will basically be in Newtonian physics, statics, dynamics, and any sort of loading situations. The last part we want to talk about today is that in our universe there are 4 basic forces in physics. There's gravitational, electromagnetic, strong, and weak. I think we all recognize gravitational, so it keeps us on the ground. Electromagnetic, it's the force that holds 2 magnets together. Strong and weak are both at the atomic level. There's strong bonds in atoms and there are weak bonds. For our purpose of this year, to get us good at being problem solvers and good at physics, we're really going to work with the weakest of the 4 forces, gravitational. It is by far the weakest of these forces in physics. The other forces are much stronger, but we'll spend most of our time dealing there. Again, remember to do a good job taking notes, organizing into sections, and having a place to do formulas that's separate.